So maximum number of registers required are 3. And now based on this table I can form a register allocation table. So I have to include the number of cycles starting from 0 to 7, input variable, R1, R2, R3, these are registers and output variable. So starting from the 0th cycle, no variable is live. In first cycle, no variable is live. In second cycle, N2 is generated. So adder number 2 generated its output. In second cycle, N2 is generated. In third cycle, N3 is generated and N2 is now live. So when a variable is generated, we don't consider it as live. The reason is already explained, and at this point N3 is generated, N2 is live. So N3 generated, N2 is live, and so the variable has to move the forward direction in subsequent cycles. So N2 will be moved to register R1. In next cycle, N2 is live, N3 is also live. So N3 is shifted to register R1, and at the same time N2 will be shifted to R2. And in fifth cycle, N2 is live and N3 is consumed in fourth cycle. So N3 is consumed in fourth cycle. So we will route this in this column, output column. And N2 is live, so it will be shifted to register R3. So the given program is periodic with iteration period 2. So now we have to also consider the periodicity in nature. So consider this iteration number first. So in the third cycle, so any iteration L will have two cycles, 2L plus 0 and 2L plus 1. So the third cycle of first iteration, N2 is in R1. So the next iteration, that is second iteration, during fifth cycle, okay, the register R1 will be occupied by the variable generated by adder 2 in some different iteration. Okay, and now coming to fourth cycle, R1 is occupied by N3. So in the next iteration, that is third iteration, during sixth cycle, R1 will be occupied by the output generated by node number 3 in some iteration. And similarly, in seventh cycle also R1 will be blocked, this time for N2. Okay, so R2 is occupied by N2 in fourth cycle. So in next iteration in sixth cycle, it will be occupied by the output generated by adder number 2 in the next iteration. The fifth cycle and R3 is occupied by N2. So in the seventh cycle, R3 will be occupied by the output of adder 2 generated in next iteration. Okay, so here you can see that N2 is generated, then shifted to R1, R2, R3. Okay, so during the fourth cycle, N2 will be generated, it will be shifted to R1, R2, R3. That's why it is blocked. So coming to this chart, during sixth cycle, N2 is live. So N2 is now at the last register. So it should be allocated in backward manner, but R2 is not available, so it will remain in R3 for 6th cycle. And in next cycle, R3 is not available, but R2 is available, so it can be now located in backward manner. So N2 will be in R2, and it will be consumed by the end of 7th cycle. So using this allocation table and folding equations, we can now derive the folded architecture. So this is the folded architecture that consists of one pipeline stage adder, two pipeline stage multiplier. Both are two input, one output system. Their input is connected to two switches. The switching instances are 12 plus 0 and 12 plus 1. And three registers R1, R2, R3. Registers is one input, one output system, and input is connected to switch. The switching instances are same. So to connect the input of this register, we have to refer this allocation table. So starting from 0th iteration, 0th cycle, no information. During first cycle, no information is given. During second cycle, N2 is generated, and in next cycle it is transferred to R1. So for this to happen, the output of adder N2 corresponds to adder, so output of adder should be connected to input of register R1 in cycle 2. 2 means 12 plus 0. So the output of adder is connected to the input of register at 12 plus 0. Okay, and in next cycle N3 is generated and it is shifted to R1. So N3 corresponds to a multiplier. So now in this case, output of multiplier should be connected to input of R1 at instance 3, that is 12 plus 1, and at the same time N2 is shifted to R2. So the output of R1 should be connected to input of R2 at instance 12 plus 1. So output of R1 is connected to input of R2 at 12 plus 1, and the output of multiplier is connected to input of R1 at instance 12 plus 1. Now during fourth cycle, N2 is shifted to R3. So output of R2 should be connected to input of R3 at instance 12 plus 0. So output of R2 should be connected to input of R3 at instance 12 plus 0. And N2 is in R3 in the next cycle. So output of R3 should be connected to its own input at instance 12 plus 1. So its output is connected to its own input at instance 12 plus 1. And R3, from R3, N2 is now shifted to R2 at instance 12 plus 0. So from R3, output of R3 is connected to input of R2 at instance 12 plus 0. Okay, so now to connect the input of adders. Okay, so coming to this circuit, first node number 1, adder number 1. Okay, so because this will be executed first, so it is receiving its input from node number 4 and node number 3, both are multipliers. So 4 to 1 is, so df 4 to 1 is 0. This means that I can directly connect the output of multiplier to one of the input of adder. And 3 to 1 is 1. This means that the output of multiplier 3 should be connected to the input of adder with one delay in between. Okay, so N3 is generated at third cycle, and after one delay it will be in R1. Okay, so the output of R1 should be connected to one of the input of adder. So output of adder is connected to one of the input of adder at instance 12 plus 0, and the output of multiplier should be, the output of multiplier is connected directly to the second input at the same instance. Okay, coming to adder number 2, one input is received from the external source and second input is received from node number 1. So df122 is 0, means I can directly connect the output of adder to its own input at instance 12 plus 1. So at this input I have provided xn, and this point is connected to the output of adder. Okay, in the similar manner I can connect the input of multipliers. So multiplier 4 will execute first, and its one input is a constant, that is a, and second input is coming from node number 2, that is an adder. So df2 to 4 is 2. This means that there should be 2 delay in between. Okay, so now refer the location table. So 2 means n2, and after 2 delays n2 will be in R2. So output of R2 should be connected to input of multiplier. So output of R2 is connected to input of multiplier at instance 12 plus 0, and at same instance A is given to the system. Okay. Coming to multiplier number 3, okay, that will be executed next. So it is receiving its input from node number 2 and a constant b. So refer equation df 2 to 3 and 5 delays. So n2 after 5 delays, 1 2 3 4 5, will be in R2. Okay, so output of R2 should be connected to output of R2, that is this one. So I have just extended this connection. So output of R2 is connected to input of multiplier at instance 12 plus 1, and second is provided with a constant b. So the output is taken from node number 2, and this is processing its input at cycle 1. So the output will be available in the next cycle, that is at 12 plus 0. So output will be taken from the output of adder, and the switch will close at 12 plus 0. Okay, so this is the final folded architecture with 3 registers.